Alright, in this example we're trying to determine the resistance of a wire. So if we picture it, we say, okay, we have a wire, and that wire is going to provide some sort of resistance based on a couple of things. It's going to provide resistance based on the area, because remember, the more narrow it is, okay, the more resistance there's going to be. But since we have a certain area, we want to take that into consideration as well. Also, we need to consider the length of the wire. Remember, the longer the wire is, the more resistance it's going to have. And also we need to take into account what this thing is made out of, or the p-value. That will tell you how fast the charges can move through the wire. So given, in this example, we're given the fact that it's a copper wire, and then it follows that with a number. That number is 1.72 times 10 to the minus 8th. Now the example doesn't have the units, but it should be in ohm meters, which is the standard unit for resistivity. Okay, it also tells us that it has a diameter of 1.5. So we're going to go ahead and take a look at this number right here, and we're going to say that this number right here is 1.5 centimeters. Now, I do know that I need to know the area in order for it to be functional in this particular equation. So I'm going to go ahead and just leave that for now. We'll get back to that in a minute. And it says, and it's 2.8 meters long. So you have L is 2.8 meters. I'm trying to find the resistance of the wire. The resistance should be in ohms. This is the Greek letter omega. So the principle that's involved here is resistance. The formula for resistance is R equals PL over A. So I look to see, do I have any irrelevant information? Okay, so I have P, which is good. I have L, which is good. I'm trying to solve for R, which is good. I do have this seemingly irrelevant information, the fact that I have the diameter, but really it's not irrelevant. And the reason why it's not irrelevant is I actually have to use that to figure out what the area is. The first thing that I need to do is I need to recognize that it's in centimeters. We don't deal with things just in centimeters, so instead we need to convert it to meters. And when we do that, 1.5 divided by 100 gives us 0.015 meters is that, the diameter. So now let's take a look at this in terms of a solution. So if I have a diameter of a circle, cross-section of a wire is going to be a circle, is 0.015, how do I find the area? That's our other formula. The area of a circle is equal to pi r squared. Now remember, if I have the diameter of 0.015, I have to divide that by 2 to get the radius as 0.0075. So now, I'm going to combine these two into one formula so I can get R equals P L divided by, instead of A, I'm going to write parentheses pi r squared. So now I plug in, I say, okay, 1.72 times 10 to the minus 8th times 2.8 divided by pi, parentheses, pi 0.0075 squared, close parentheses, close parentheses. The reason why I put multiple parentheses here is only the 0.0075 is squared. So now I put it into my calculator, and when I do that, I get 1.72 e minus 8 times 2.8 divided by parentheses pi, parentheses 0.0075 squared, and then you close the two parentheses. And when you do that, you get a number like 2.72 times 10 to the minus 4th, and that's in ohms. So I found a resistance. That's what I was trying to find. So now I say, does my answer match what I was trying to find? That is correct. And is my answer reasonable? This is a very, very low resistance, but we're talking about a copper wire that is pretty thick, and it's very, very, very short. So yes, we would expect it to have a small resistance.